When we talk about leaving Earth, the conversation almost always centers on Mars. Pop culture and space agencies treat it as the only logical next step for human civilization. But look at this desolate rocky landscape. Mars is effectively a vacuum, with an atmospheric density just 1% of Earth's. It lacks the basic planetary insulation required for life. Without a thick atmosphere to block cosmic rays, the surface is a high radiation environment. Building a colony there means fighting a constant uphill battle against physics just to keep the occupants alive. To find a more viable alternative, we have to look 1.4 billion kilometers away to Saturn's orbit. This is Titan. For decades, it was a mystery hidden by thick, opaque clouds. That changed in 2004, when the Cassini-Huygens mission arrived to see what was underneath. The probe sent back this view from the surface. These smooth, rounded stones are evidence of a world shaped by active liquid erosion, much like the riverbeds on Earth. However, the chemistry here is alien. The water is actually liquid methane. The temperature is a freezing negative 179 degrees Celsius, and the journey there takes 7 years. Despite those extremes, Titan is the only other world with a complex, functional climate system. It has clouds, rain, and surface liquids, providing a foundation for colonization that Mars cannot match. In space, atmospheric pressure is the most important metric for survival. It determines how much radiation you absorb and the difficulty of building a pressurized habitat. This chart compares the three worlds. Titan's atmosphere is 95% nitrogen, but 1.5 times denser than Earth's. That thick gas column is a natural shield, deflecting lethal cosmic radiation and incinerating micrometeorites, providing safety Mars simply cannot offer. Then there are the resources. Titan is covered in vast lakes of liquid methane and ethane, including the massive Kraken Mare, which is larger than the Great Lakes of North America. These lakes contain hundreds of times more energy than all of Earth's oil reserves combined. While any colony would still need to extract oxygen from ice to burn it, having a massive hydrocarbon supply provides raw materials for power, fuels critical heating systems, and drives local manufacturing on a scale Mars cannot match. This specific combination of high pressure and low gravity creates a world where the rules of movement are totally different. On Titan, you have just 14% of Earth's gravity, but the air is highly buoyant. This means that if you strapped on a set of wings, you could likely flap your arms and fly through the sky. Human-powered flight, a dream on Earth, is a basic law of physics on Titan. We still have to account for the extreme cold and the 7-year travel time, but those are engineering challenges. We can build better engines and better insulation. Mars has a planetary deficit, a missing atmosphere, that no amount of human engineering can replace. Turning Titan into a home isn't just a theory. Space agencies have already outlined a multi-decade roadmap to make it a reality. Step 1 begins in the 2030s with NASA's Dragonfly. This nuclear-powered drone will map the terrain and identify the best spots for a permanent human presence. By the 2050s, we plan to land the first human crews. They will live in massive insulated domes built from advanced composites that stay flexible even at negative 179 degrees. In the 2060s, resource extraction begins. We will melt subterranean ice to create water and oxygen while pumping methane from the lakes to produce fuel and the plastics needed to expand the base. This timeline is based on utilizing local materials. Instead of shipping everything from Earth, we are using the Moon's natural chemistry to build an industrial hub in the outer solar system. Beyond the 2070s, the colony would move underground, creating vast, shielded networks that could eventually house thousands of people. When you look up at the night sky today, Saturn is just a distant, cold point of light. But we need to look past the rings and recognize that hazy orange moon for what it really is. Living on a methane moon might sound like science fiction, but history is defined by those who followed the data to the next frontier. Titan represents our most realistic path for a long-term presence beyond Earth.